Hello and welcome to today's webinar, where I will be talking about trace level nutrient analysis in environmental samples with the Bluvision discrete analyzer, scalar analytical. To begin, before I get to the analyzer itself, I first wish to define some of the requirements Scalar had in mind during the development of its discrete analyzer. These are accuracy and quality. Of course, all laboratories have a need for correct, precise, reproducible results according to norms, whether these are national norms, international norms, maybe an internal norm, or a company-wide norm. Ease of use and long walk-away time, the goal here being minimum operator involvement and attendance to the analyzer. Much of that is driven by our own flexible software package, thanks to the intelligent ordering and prioritizing of the workflow of the laboratory. And that really creates a situation where operators only need to keep adding or feeding samples and cuvettes to the instrument, as well as keep it clean during any downtime with a set of easy and simple maintenance steps. Speed and throughput. Modern laboratories are a result factory, which require accurate results as fast as possible. And the ability to analyze samples in small or large batches while they are still stable and fresh is critical. And we have flexibility, reporting abilities, so being able to respond in changes to the demands of the analyzer. That could be at a daily level, so the ability to add emergency or priority samples to a batch, as well as say more global changes, and in the sense of being able to respond to changes or norm revisions, legislation changes, which might require the reporting capabilities of the lab to improve, putting pressure on the analytical performance of the lab and therefore the instrument. And of course, the ability to import and export results and to report different results in different formats. I think at this stage, it's also useful to give some examples of the typical parameters analyzed in the environmental sector. And while this list is not exhaustive in any sense, I've selected the most commonly requested parameters, which are of course nutrients, as you see, ammonia, phosphate, some other nitrogen species. But what we also see now, we're being asked to supply more and more analyzers with methods for certain metal analyses. So you see here also chromium-6, iron, and aluminium. And these parameters can all be analyzed in a wide range of sample matrices, which is a requirement of the environmental market. And all of these methods are supplied, all of these parameters are analyzed by fully developed methods, which are supplied with the analyzer. Which brings us to the question, why did Scalar develop a discrete analyzer specifically for the environmental sector? Well, there are three main reasons. The first of which being customer demand. So what we know is that the original design of current discrete analyzers in the market was based on clinical requirements and therefore do not fully satisfy the needs of environmental labs at all times. And the main difference there is that clinical labs require measurement within a very narrow range of concentrations and also see very little diversity in terms of the types of sample. Whereas an environmental lab requires measurement of both very low and very high concentrations of an analyte and in a wider, more diverse range of samples. And what allowed us to develop this is our experience. So Scalar as a company has around 50 years of experience in wet chemistry automation. So all of that knowledge, those techniques, know-how gathered from an international worldwide install base really allows us to call it a combined and consolidated knowledge. And of course, our existing package or portfolio of complementary instruments, which provide automation solutions for the various parameters in their various combinations throughout environmental labs. And here the first of which is our SAM++ continuous flow analyzer, segmented flow analyzer. And this is a wet chemistry automation platform for the analysis of complex parameters. So that's to say parameters requiring automation of more complicated sample handling steps, such as digestions, distillations, extractions, so on. And these can be configured for small or large sample batches for simultaneous or sequential analysis. Just a few examples here: total cyanide, phenol, anionic surfactants. Just a few examples there of what I mean by analytically complicated parameters. Total nitrogen, total phosphate, of course. Then we have our SP2000 robotic test kit analyzer. So this is an automation platform for simple colorimetric applications in test kit form, generally intended for small volumes and batches, or maybe an in-process test or set of tests. And in the environmental sector, it's commonly supplied primarily as a total automation solution for COD analysis, chemical oxygen demand, but with several possibilities to combine with other nutrient parameters as well as TN and TP, and also the possibility there for the analysis of some physical parameters such as pH and electroconductivity. And what these two do is leave space in between for one further analyzer to occupy, and that is our Bluvision discrete analyzer. So here we have again a wet chemistry automation platform for high throughput analysis of simple colorimetric applications. And the advantages here being speed, minimal waste, minimum reagent usage, and what you have here is the ability to assign specific tests to specific samples. So you have that selectivity at the level of every sample. So again, as we come closer to the analyzer itself, I think it's also good just to overview what discrete analysis is. Well, and what is a discrete analyzer? A discrete analyzer can be thought of as an automatic and sophisticated pipetting station, which works as follows. So into your cuvette, we have the addition of sample, we have the addition of a reagent, and this is all taking place in an individual reaction position in our cuvette. So we have our liquid addition, we have a mixing, maybe and then a first measurement. Then we move to the addition perhaps of our third reagent, and then you will have during which time, after a mixing step, you will have your color development, so the reaction proceeds to completion. At the end of this, you have your color product, which is measured and quantified in the software. So again, the principle here is that each test occurs in its own separate or discrete reaction position, and that's in contrast to continuous flow technology, where you have a continuous or constant stream flow of samples and reagents through a flow cell for measurement. So the schematic you see here, the animation we've just seen, how does that translate into an analyzer, into hardware? Well, that translates into our Bluvision analyzer and is the subject of today's webinar. So you see here, starting on the left-hand side of the analyzer, what I'm going to do is take you through the analyzer now in roughly the order a sample would go through the system. So we're going to start on the left-hand side of the analyzer and our sample and reagent tray, where our samples and reagents are loaded, and that's what you see here in the movie. So we have 100 sample positions distributed over 5 racks of 20. They're going in your reagents, with the darker canisters there for light sensitive reagents. So on reagents, you have 24 positions for 50 ml reagent containers, with an additional space for 8 containers of 10 ml, and these are usually reserved for stock solutions for making your calibrations, as well as any QC samples. This area, this compartment of the analyzer is cooled, which means that the Bluvision actually cools both the samples and the reagents. That has 2 main advantages. The first being sample stability until the run or the batch is complete. Other systems only cool the reagents, which is good for the life of the reagents naturally. But with environmental samples, we have to think about the stability of the samples themselves, which makes preserving the integrity of the samples until analysis is complete. Yeah, that becomes very important, because you want your volatile compounds, such as ammonia, to stay in solution so it is there to be picked up for analysis. And if you think further into our analysis process, any post-dilution, so that the ammonia that is there now has to be there 30 minutes from now when we come back for any, say, post-dilution work to avoid discrepancies in those results. As I said, in cooling both the samples and reagents, the shelf life, the onboard shelf life of the reagents is also preserved. But what this does actually for the lab is actually place less demands on the location of the analyzer in the lab, because any fluctuations in the temperature of the laboratory cannot affect the samples or the reagents, and therefore don't impact on our analyses in any way. Now, just staying with the samples for now. So I've mentioned the wide range of samples that needs to be analyzed in an environmental lab, but we need to be sure that this is done in an analytically correct way in terms of sample handling, ensuring that there's no effect from one sample to another by contamination, and also that the environment or the location around the analyzer does not contribute in any way to our results. So that's particularly in the case of ammonia, which in the right conditions is both very volatile and very soluble. So to eliminate this effect, the Bluvision has integrated an overpressure and exhaust system whereby a continuous stream of inert gas passes over all areas of the analyzer. And what that creates is a blanket of gas which takes any volatile gases downwards and out of the analyzer. And that's what you see here in the picture. You have your inlets for the gas at the top, and further back and downwards the outlet for the exhaust fumes generated. And it's actually with this exclusive technology that we solve a very common pain point of many labs. And while this is a standard built-in feature, the customer actually has a choice as to whether they use it or not, depending on the exact situation of their laboratory. So with our samples and reagents now loaded, we can now proceed to pickup, and that's done by two long life, high precision dispense pumps. One for smaller volumes, 500 microliters, and that's for the pickup and dispensing of your reagents and samples, and a larger one primarily used for making dilutions and also for flushing the inside and outside of the needle between handling steps. You see here, 5 million cycles as a lifetime, maintenance and calibration free. And just a quick note on what I mean by calibration free is that the pumps themselves do not require calibration, but in case we do realize that it can be required for audits and accreditation purposes, and it's for that reason that the software does contain a calibration sequence to allow customers to do this. So now we've picked up our sample, it has to be dispensed into the cuvette. And that is done by our multifunctional smart needle. So a few points about these functions. As you see in the video, the pickup of the reagent and the dispensing into the cuvette, always with a rinse step in between. What you see there, so now we go back again, and we pick up our sample. So pick up, dispense, rinsing, and that mixing, as you see here, is done by an oscillation in the cuvette and also just the force of the dispensing itself. Of course, the needle is also responsible for all of the dilutions together with the pumps. And just a quick point on the dilutions here. On the Bluvision, it is possible to perform dilutions in both the cuvette and a sample tube, and that actually offers great flexibility over a much wider dilution range, because dilutions of up to 1,000 times can be carried out in a sample tube in a single step, and in the cuvette a 200-fold dilution is also can also be done. The needle is thermostated and to a user definable temperature, and what that ensures is a consistent temperature during the pickup and transfer of samples and reagents to the cuvettes, ensuring that all samples are treated the same. And lastly, the needle is also acting as a capacitive level sensor, which actually gives us a real-time monitoring and an output of reagent levels, and therefore the remaining analysis capacity. By detecting the liquid level of samples and reagents, the Bluvision can automatically report when a reagent is soon depleted and needs to be refilled. And actually a warning will be displayed if an operator attempts to start a run containing more tests for which there is actually reagent available. So we've seen where our samples and reagents are coming from. So now we can turn our attention to the cuvettes and where they enter the analysis process, which is starting at the autoloader. So the autoloader can hold 4 blocks of 12 cuvettes, and each cuvette contains 10 test positions. So that gives you an onboard capacity there of 480 test positions in the autoloader. And as I mentioned in my introduction, for longer runs or bigger batches, operators simply have to keep adding cuvettes. So from the autoloader, our cuvettes pass into the cuvette tray, which is where all reactions and measurements take place. So what you see here is the loading from the autoloader into the cuvette tray, and with its capacity of 16 cuvette blocks, again, each one containing 10 reaction positions, takes us to a total of 640 onboard test positions, and that's what gives us our long walk away time. So just to take a closer look at the cuvettes themselves. So these are made of a high optical quality plastic. As I mentioned, each contains 10 test positions. They're disposable, which eliminates carryover from poorly washed or previously mishandled cuvettes. And this combination of a high total volume and a 15mm optical path length actually allows detection and quantification limits previously only available by continuous flow technology, but now here combined with all the natural and inherent advantages of discrete analysis. So if we just look at some numbers, so as you see, just quickly back to basics. So we're thinking of our Lambert-Beer law, where our longer path length gives us a higher sensitivity, which gives us lower detection limits, and by extension, better quantification possibilities. And that's what you see here. So of particular interest here are the sub-ppb MDLs for ammonia, as well as nitrate and nitrite, 1 ppb there for phosphate. And what that actually gives us, the additional value of this is that it allows meaningful results to be achieved even at these trace levels in an analytically correct and robust way. And staying with detection, we move to the detector itself, and that consists of a halogen lamp, a lens, the necessary filters for our particular set of parameters, a splitter and a photocell, and these combine as follows. So we have our lamp, our light source, and the light from which is focused, condensed, and passes through the necessary filter for our analyses. Then we come to our splitter with a large portion of the light passing through the sample cuvette itself, through the color product of our reaction to the photocell, and then onwards to for a quantification and a calculation in the software. The rest of our light passes to a reference detector, and what that's really doing is just correcting for any electrical noise, fluctuations in the lamp. So this is a dual beam or a split beam detector. Now, as you can see here, the filters that we need for our analysis are actually accommodated or housed in a wheel, which makes them actually very, very simple and easy for customers to change. So no engineer call out required for that. And that's actually done through a set of prompts through the touchscreen on the front of the analyzer. Keeping in mind that certain parameters actually share the same wavelength for measurement, and that expands the amount of parameters that can be measured in an analytical run. So depending on the exact combination of filters in the wheel, up to 15 parameters can be analyzed during a single run. So we've reached the end of our analysis. Our results are calculated and now visible in the software. So what happens to the cuvettes? These need to be removed, of course, from the analyzer to our waste container. Now, the interesting point here is that we have the ability to segregate the waste based on the type of waste that it is. And there's two main reasons for that. The first is safety. So being able to separate waste based on whether they are acids and bases, or maybe acids or reagents containing potentially liberatable cyanide compounds or other toxic chemicals. And this is, of course, commercially interesting. So separating hazardous and non-hazardous waste is quite a significant contribution to the total running costs of a laboratory. So it's actually senseless to pay this premium for the disposal of relatively harmless waste. And just another mention of the overpressure exhaust system that we saw earlier in the presentation. This same mechanism is present in this section of the analyzer, and what that does is actually just prevent re-entry of any fumes from our waste container. Just prevents them from re-entering the reaction zone of the analyzer. And that brings us to the final piece of hardware to show you today, which is the touch screen at the front of the analyzer. So in addition to the computer-based software, which I'll come to in a moment, the hardware itself is controllable through a touch screen on the front of the analyzer, and this provides control over the main functionalities you see listed here. So that's an output of say the temperatures of various areas of the analyzer, the filters, the ability to change filters, adding reagents, cuvettes during analysis. And just to give you one example here of how to add a priority sample during a run, they simply follow this set of prompts, add the sample, and then they're able to close the hatch, resume the analysis, and assign the necessary tests in the software. So moving to the last part of today's webinar, I'm now going to overview what ties all of this together, which is our own software package, Discrete Access. So here you see a modern, easy to use interface through which all our analyses are set up, methods are assigned, and data handling and reporting is performed. So what you're seeing here is the user only has to enter the sample IDs or upload them, import them from a LIMS, and select the desired tests if that's not part of what you import. This, of course, can be sped up by interfacing the software with a barcode reader. And now, once we've hit start, a set of calibration or sets of calibration standards will be prepared from an onboard stock solution. Likewise, any necessary pre-dilution of samples is performed automatically, again, either in a sample tube or in the cuvette itself. But of course, by this time, the analyst is already able to walk away and leave the analyzer for the duration of the run, as the sample sequence is optimized automatically, and also giving us the possibility to have priority analyses, for example, if you want to run all of your ammonia tests first. And throughout the run, as the results start coming out, if a sample goes over range during analysis, the sample is automatically rerun in a more appropriate or more correct range, or it can be post-diluted and rerun on that same range. So that option in sample handling by the analyzer is user-definable and requires no return to the analyzer for any intervention, so no button push, no click to confirm, and so on. Which brings us only to the last part, the data handling. So results can be printed using a user-definable print format for export to LIMS, or whether that is a physical hard copy print. So you only see the data of interest to your operation, and as well as, or instead of this, as I say, these results can be exported to LIMS for further data handling, and all the file types are XIL, CSV, ASCII files, so on. And just a quick note on quality as well. Extensive QC protocols are available, such as CLP, with an optional for the 21 CFR Part 11. That includes all your password protection, various privilege levels for different levels of operator, as well as preserving data integrity, safety, giving you the audit trails for your accreditation purposes, and so on. So I'm now going to begin my summary of the features that we've seen that make the Bluvision a very, very solid choice for analysing nutrient parameters at trace level. I think the most significant of these is our unique 15mm cuvettes, which give us that additional sensitivity to allow us to detect sub ppb levels and therefore to quantify reliably at trace levels. Again, we're now seeing detection limits previously confined to flow analyses technologies now being combined with the overall convenience of discrete analysis. And the fact they're disposable removes the possibility of poor results coming from contamination due to mishandling and poor cleaning of the cuvettes, and that really contributes significantly to the MDLs and LOQs we saw during the presentation. And this elimination of contamination is further enhanced by our overpressure exhaust system, which eliminates the effect of adjacent samples, or the effect these can have on one another, as well as removing the effect of the environment around the analyzer and allowing a wide range of samples to be analyzed in a single run or batch. Just keeping in mind that that same system ensures no waste fumes are able to re-enter the reaction and measurement zone of the analyzer from our waste. Cooling both the reagents and the samples, so extending the onboard lifetime of reagents, but also preserving the sample for the duration of the run by keeping volatile compounds in solution, meaning any post dilutions can be done accurately and without discrepancies. Then we have our thermostatic needle, our smart multifunctional needle for consistent sample handling and constantly giving that output by functioning as a capacitive level sensor, warning users when their reagents are depleted, and together with these high precision maintenance free pumps allows a greater flexibility across a wider dilution range by allowing both dilutions in the sample tube and or in the cuvettes themselves. An extended walk away times, 640 onboard test positions, creating a situation where minimal operator involvement is required to achieve a high throughput in terms of results, where it's only necessary to add more cuvettes and samples for larger batches or overnight or round the clock analyses. Then we have the safety and cost efficiency benefits of being able to segregate our waste, again, in a completely user definable way, according to the particular demands on waste disposal of a particular laboratory. And to complete the package, the analyzer is supplied with a set of methods or suite of analyses from our own library of ready-to-use methods. And that, while this combination of methods is always customer specific, our methods are based on well-accepted international norms with the opportunity for customers to use their own methods or adapt methods according to their own specific requirements or changes in those requirements. That concludes my presentation for today. That concludes today's webinar. I thank you for your attention, and if you require any more information, please visit us at www.scalar.com. Thank you.